Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC P0335, a diagnostic trouble code for Honda Pilot models from 2016 to 2022. This specific code indicates that the crankshaft position CKP sensor is not providing a signal. The CKP sensor is crucial for the engine's control module to determine the position of the crankshaft, which directly affects ignition timing and fuel injection. If this sensor fails, it can lead to performance issues, stalling, or even a no-start condition. The CKP sensor is located near the engine crankshaft, typically at the lower part of the engine near the flywheel, which allows it to monitor the crankshaft's rotation. In this presentation, we will explore the symptoms, causes, and detailed troubleshooting steps to resolve DTC P0335 effectively. The DTC P0335 specifically refers to the crankshaft position sensor signaling a malfunction with the message "no signal." The CKP sensor plays a pivotal role in determining the rotational position of the crankshaft, which is essential for the fuel injection and ignition timing across Honda Pilot vehicles from the years 2016 to 2022. When this sensor fails to send a signal, the engine control module, ECM, cannot accurately sync the timing for fuel and spark, which can lead to various performance issues. The CKP sensor is typically located near the lower section of the engine, usually adjacent to the flywheel, where it can effectively monitor the crankshaft's rotational speed. This location is critical for the sensor to function accurately. In case of no signal, it may result in diagnostic trouble codes being triggered, thus requiring immediate attention to avoid further engine performance issues. There are several potential causes for DTC P0335 that warrant careful inspection. Firstly, an open circuit in the CKP sensor wiring could inhibit the signal transmission required for the ECM's proper functioning. If the wire is damaged or severed, the sensor won't be able to send essential data, resulting in a no-signal indication. Secondly, the CKP sensor itself may have malfunctioned due to wear or internal failures, which would eliminate its ability to detect the crankshaft's position properly. Lastly, faulty connections or corrosion at the sensor or the powertrain control module, PCM, could hinder signal transfer, leading to miscommunications within the vehicle's electrical system. It's critical to approach these possibilities methodically to ensure accurate diagnosis and effective repair. The symptoms associated with DTC P0335 can be quite noticeable and disruptive. One primary symptom is engine stalling, which occurs when the engine suddenly dies while driving or at idle due to the ECM losing its ability to regulate fuel and ignition timing. This may cause considerable safety hazards on the road. Additionally, poor acceleration can be observed as the engine struggles to gain speed, often leading to a frustrating driving experience. Drivers may also face difficulties starting the engine, which can seem to turn over but fail to start completely due to improper timing set by the failed CKP sensor. Identifying these symptoms early can aid in quicker diagnosis and repair, preventing further complications down the line. The first step in troubleshooting DTC P0335 is to confirm whether the code is indeed present after clearing any previous codes. Begin by turning the vehicle's ignition to the on position, ensuring all electrical components are powered without starting the engine. Once in this mode, use the HDS or Honda Diagnostic system to clear any existing DTCs, including P0335. After clearing, start the engine and monitor the system using the HDS for any pending or confirmed DTCs. If P0335 reappears, it indicates a confirmed failure. and you should proceed to the next troubleshooting step. If the code does not reappear, this may suggest an intermittent issue worth investigating further, including checking the CKP sensor and powertrain control module connections. In the second troubleshooting step, we're going to check the integrity of the IGP line, which is crucial for the CKP sensor's operation. Begin by turning the vehicle to the off lock position to ensure safety while working with electrical components. After this, disconnect the 3P connector from the CKP sensor. With the sensor disconnected, switch the ignition back to the on mode to facilitate voltage measurement. Using a multimeter, measure the voltage between test points at the CKP sensor connector. Test point 1, which is CKP sensor connector, pin number 1, and test point 2, which is the body ground. If you detect battery voltage at these points, it signifies that the IGP wire is functioning correctly, allowing you to advance to step 3. If there's no voltage detected, it's indicative of an open circuit in the IGP wire, and repairs should be made accordingly. The third troubleshooting step involves further diagnosing the CKP connector's CRK line condition. With the CKP sensor 3P connector still disconnected, and while the vehicle is in on mode, measure the voltage again, focusing on test point 1, which is CKP sensor connector pin number 3, and test point 2, which is the body ground. What you're aiming to find here is an approximate voltage level of 5.0 volts. If this voltage is present, it indicates the sensor's ability to send a signal to the ECM and that the circuit is functioning as expected, allowing you to move on to step 4. If you observe discrepancies in voltage, or if there's none present, you may have to investigate further and potentially proceed to step 5 for more thorough checks of the wiring and connections. In this step, we focus on ensuring the integrity of the CRK LG line, keeping the CKP sensor 3P connector disconnected. Measure the voltage between test points 1 and 2, both within the CKP sensor connector. Test point 1 is the first pin, and test point 2 refers to the second pin of the CKP connector. Again, the vehicle should be in on mode during this measurement. A successful check will show battery voltage between these two pins, which indicates that the wiring and connections between the CKP sensor and the ECU are operational. If confirmed, the next logical action is to replace the CKP sensor, as it would be the primary suspect for any persistent signal issues. If battery voltage is not found, you'll need to repair the open circuit in the CRK LG wire leading back to ground G101. Next, we move on to inspect for any potential short circuit issues within the CRK line. Start by turning the vehicle off completely and then use the HDS to jump the SCS line. This is a safety precaution designed to disable the airbag system during diagnostic procedures. Allow more than a minute, ensuring that the system remains inactive. Following this, disconnect the PCM connector C, which usually houses 51 pins, and check for continuity between test point 1, PCM connector pin number 11, and test point 2, which is the body ground. This test indicates whether there's a short circuit in the CRK wire leading to the PCM or the CKP sensor. If continuity is present, it would confirm a short that requires repair. If not, you can proceed to step 6 as no shorts have been detected. The final troubleshooting step is directed at confirming the integrity of the CRK line further. You will need to connect terminals A and B, with terminal A being CKP sensor connector pin number 3, and terminal B being body ground. After establishing this connection, check for continuity between test point 1, which is PCM connector pin number 11, and test point 2, the body ground. If you find continuity at this juncture, it indicates that the CRK wire is functioning correctly. At this point, it's advisable to consult any authorized service information regarding the DTCs or symptoms being investigated. As a next step, consider substituting a known good PCM if issues persist, or else inspect for other faults that could be leading to the DTC P0335. Once you have performed all necessary repairs according to the outlined steps, it is crucial to verify the effectiveness of your repairs. Start by conducting a test drive of the vehicle under varied conditions to ensure that the engine operates smoothly and without issues. During this drive, observe any signs of performance glitches or warning lights being triggered. After driving, connect the HDS to the vehicle again to check for any reoccurrence of DTC P0335 or related codes. If the code does not return and the vehicle operates normally, you can confidently conclude that the repair process has been successful. Should the DTC reappear, it suggests that further investigation is needed, potentially focusing on different areas that may not have been thoroughly checked. Preventive maintenance is essential in averting issues like those indicated by DTC P0335 in the long term. A good practice is to regularly inspect the wiring harness associated with the CKP sensor to ensure there are no visible signs of wear, fraying, or damage. Focus on ensuring all connections are clean and free of corrosion, as even minor issues at connection points can lead to significant problems with signal transmission. It's also important to avoid settings that might induce vibrations on engine components, as this could adversely affect sensor function. Additionally, conducting regular diagnostics using tools such as the HDS can pinpoint developing issues before they escalate, ensuring optimal vehicle performance. In conclusion, the DTC P0335 associated with the CKP sensor must be addressed promptly to maintain the Honda Pilot's overall engine performance. This guide detailed a systematic process for diagnosing and troubleshooting the CKP sensor no signal code, spanning from verifying the DTC to exploring the wiring and sensor integrity. It is crucial to follow each step carefully to uncover the root cause of the issue, ensuring that repairs are effective. Furthermore, preventive maintenance, including regular checks on wiring and connections, can significantly reduce the risk of similar problems arising in the future. Keeping the vehicle in optimal condition is not only beneficial for driving experience, but also significantly enhances safety while on the road. Please like and subscribe to the channel. See you next time!